Good morning, students. Today our topic is principles of negative current feedback. In the previous class, we study about the principle of negative voltage feedback, and today we will study about principles of negative current feedback. Now, in this method, a fraction of output current is feedback to the input of the amplifier. In other words, feedback current IF is proportional to the output current I out of the amplifier, and figure below shows the principle of negative current feedback. This circuit is called current shunt feedback circuit. This circuit is called current shunt feedback circuit, and a feedback resistor RF is connected between input and output of the amplifier. This amplifier has a current gain of AI without feedback, and it means that a current I1 at the input terminals of the amplifier will appear as AI into I1 in the output circuit. So I out is equals to AI into I1. Now a fraction of this output current is feedback to the input through RF. This is the circuit diagram for negative current feedback. AI is current gain. AI is current gain, and this is the circuit for feedback, and RF is the resistances which is connected between the input and output. Now feedback current IF is equals to MI into I out, and feedback fraction MI will be equal to IF divided by I out. Next is current gain with negative current feedback. Now from the above equation it is clear that I in is equals to I1 plus IF. In this diagram it is clear that I in current is equals to I1 plus IF. Now put the value of IF, then we get I in is equals to I1 plus MI into I out, and I out is equals to AI into I1. So on putting this value we get I in is equals to I1 into 1 plus AI MI. I in is equals to I1 into 1 plus AI MI, and current gain with negative current feedback will be equal to AIF is equals to I out divided by I in is equals to AI upon 1 plus MI AI. AIF is equals to AI upon 1 plus MI AI. This equation looks very much like that for the voltage gain of negative voltage feedback amplifier. This is the similar equation as we get for the negative voltage feedback, and there are some points may be noted carefully. First is the current gain of the amplifier without feedback is AI, and however when negative current feedback is applied to the current gain applied however when negative current feedback is applied, then the current gain is reduced by a factor 1 plus Mi into AI, by a factor 1 plus Mi into AI. Second is the feedback fraction Mi has a value between 0 and 1. It is also similar to the negative voltage feedback. Now the negative current feedback does not affect the voltage gain of the amplifier. Voltage gain remains the same. It will not affected by the negative current feedback. Effect of negative current feedback. First, on the input impedance. What is the effect? Decrease the input impedance. The negative current feedback decreases the input impedance of the most amplifiers. And for this now, let Zin is equals to input impedance of the amplifier without feedback, and Zin dash is equals to input impedance of the amplifier with negative current feedback. And this is the circuit diagram for finding the input impedance with negative current feedback. And it is clear from the above figure that now it is clear from the above figure that Zin is equals to V in divided by I1, and Zin dash is equals to V in divided by I in. So V in is equals to I1 Z in, and I in will be equals to I1 plus IF. It is clear from the figure that I in is equals to I1 plus IF, and put the value of IF, then we get I in is equals to I1 into 1 plus Mi into Ai, and Z in dash is equals to Z in divided by 1 plus Mi into Ai. Z in dash is equals to Z in divided by 1 plus Mi into Ai. The input impedance of the amplifier is decreased by a factor 1 plus Mi into Ai. Next effect is increase the output impedance. It can be proved that the negative current feedback, with the negative current feedback, the output impedance of the amplifier is increased by a factor 1 plus Mi into Ai, by a factor 1 plus Mi into Ai, and Z dash out is equals to Z out 1 plus Mi into Ai. Z dash out is equals to Z out 1 plus Mi into Ai. This is the output impedance. With the negative current feedback, Z dash out is equals to Z out into 1 plus Mi into Ai. Now third effect is increase bandwidth. It can be shown that with negative current feedback, the bandwidth of the amplifier is increased by a factor 1 plus Mi into Ai. Bandwidth dash is equals to bandwidth into 1 plus Mi into Ai, and here bandwidth is equals to bandwidth of the amplifier without feedback, and bandwidth dash is equals to bandwidth of the amplifier with negative current feedback. So these are the effects. First effect on input impedance, which is decrease the input impedance, and second effect is increase the output impedance. Third effect is increase bandwidth of the amplifier.